Okay, so in this class I'm going to talk about the second fundamental principle of counting, and before I come back to the principle, let me just kind of go through an example. I'll come back to the fundamental principle in a second. A deli has a lunch special which consists of choosing exactly 2 courses from a soup, a sandwich and a dessert. They offer the following choices: soup, tomato, chicken, noodle or vegetable is 3 choices of soup. Sandwich, chicken, ham, tuna or roast beef, there's 4 choices of sandwich. Dessert, you can choose a cookie or a pie, 2 choices for dessert. How many lunch specials are there? Now we have to be a little bit careful here. I'm not choosing 3 courses, I'm only choosing 2. I have to choose exactly 2 courses. And there are different ways to approach this problem. In fact, there are 3 different approaches I can take to choosing 2 courses. The first approach I could take is to choose a soup followed by a sandwich. Or I could take a different approach. I could choose a soup followed by a dessert. So for soup followed by dessert, soup followed by a sandwich, or a soup followed by dessert, or I could choose a sandwich followed by a dessert, because I'm choosing 2. So there are 3 different approaches in order to establish how many different lunch specials there are here. I could approach this problem in one of 3 ways. Remember, the problem is the experiment is to choose a lunch special, and there are 3 different approaches to that. First of all, I could choose soup and dessert. That would be 1 lunch special. It's 2 courses, which we're told it has to be 2 courses. I could choose a soup and sandwich, 2 courses. I could choose a sandwich and dessert, 2 courses. 3 different ways: soup sandwich, soup dessert, or sandwich dessert. So how many ways can I complete each of these things? So first of all, I could choose a soup and a sandwich. And the number of ways to choose a soup and a sandwich: well, task 1 is to choose a soup, task 2 is to choose a sandwich. The number of ways to complete task 1 is 3. The number of ways to complete task 2 is 4. So the number of ways to complete task 1 is, task 1 followed by task 2 is 3 times 4. To choose a soup followed by dessert, okay, 2 tasks in that experiment. Task 1, choose a soup. Task 2, choose dessert. The number of ways to complete task 1 is 3. The number of ways to complete task 2 is 2. The number of ways to complete task 1 followed by task 2 is 3 by 2. That's the first fundamental principle. So it's 3 by 2. Sandwich followed by dessert: 4 ways to choose a sandwich, 2 ways to choose a dessert. So 4 by 2 ways to choose a sandwich followed by dessert. So there's 12 ways I can choose a soup, then a sandwich. There's 6 ways I can choose a soup or a dessert. Soup and then a dessert. And there's 8 ways I can choose a sandwich followed by dessert. So how many ways altogether? Well, what we're talking about is I can complete the experiment in 12 ways, or in this 6 ways, or in these 8 ways, and it should logically make sense that we're just adding up all together. We're just adding up. There's 12 ways I can choose a soup followed by a sandwich, 6 ways I could choose soup followed by dessert, 8 ways to choose a sandwich followed by dessert. So there must be 26 different ways that I can choose a lunch special. Okay? There are 3 different approaches. Within each approach, there are 2 tasks. So the second fundamental principle of counting essentially says this. It says, suppose there are different approaches to completing an experiment. The number of ways that the experiment can be completed is equal to the sum of the number of ways each approach can be completed. And within each approach, in this case, there were 2 tasks. Okay, so that's the second fundamental principle of counting. This or tends to mean add. Okay, if we're talking about soup and then choose a sandwich, that and then tends to mean multiply. So or tends to mean add, and then tends to mean multiply. Okay, let me look at another question. It says a security code for a door consists of 2 letters followed by 2 digits. How many such codes are possible? Okay, So let's look at the first question first. How many such codes are possible? Choose 2 letters, then choose 2 digits. Okay, so there are 4 tasks here. Task 1 is to choose a letter for the first position. There are 26 ways I can choose a letter for the first position. Task 2 is to choose a letter. It doesn't talk about any repetition being a problem, so I can repeat letters, no problem. Task 3, how many ways could I complete task 3, which is to choose a digit? There are 10 digits I can choose from. And task 4 is to choose a digit. It doesn't mention that I'm not allowed to repeat digits, so there are still 10 ways I can choose a digit. 26 ways to complete the first task, 26 ways to complete the second task, 10 ways to complete the third task, 10 ways to complete the fourth task. So there are 26 by 26 by 10 by 10 ways to complete task 1, followed by task 2, followed by task 3, followed by task 4. I'm choosing a letter, and then a letter, and then a digit, and then a digit. So we're 26 by 26 by 10 by 10. So I think I'm getting 67,600 there. Bit of calculator work. How many such codes? My units here would be codes. How many codes are possible? Well done. 67,600 codes are possible, with 2 letters followed by 2 digits. Second part is slightly more interesting. Question says, how many ways can I form a code if I want my code to contain the letter J and to have no repeated letters or digits? So this is slightly more complicated. And there are actually 2 approaches here. There are 2 approaches because there's 2 letters at the start. I want to have the letter J, so I could put the letter J in the first position, or I could put it in the second position. So we're dealing with this or, and again we said by the second fundamental principle of counting, that means we're adding. We can have 2 letters, that we could have the J in the first position, for example J, and then another letter, and then a digit, and then a digit. Or we can have a letter, and then a J, and then a digit, and then a digit. So there's kind of 2 different approaches here. So in the first case, let's look at the first case first. Task 1 is to put J, to choose the letter J. There's only one way, one possible choice of the first letter if I'm starting with J. And then I'm looking at the next thing. I'm not allowed to have any repeated letters or digits. I've already used the J in the first position, so there are only 25 letters open to me to put in the second position. Then I'm going to choose a digit. There are 10 digits to choose, but I'm not allowed to repeat, so there'll only be 9 digits left to choose for the fourth position there. So task 1 is to place the letter J in the first position. There's only one option there. I have only one choice. Task 2 is to choose a different letter. Task 3 is to choose a digit. Task 4, choose a different digit. The number of ways to complete those tasks, that experiment, or that approach, I suppose, is 1 by 25 by 10 by 9. And for the second option, well, actually, if you look, it's going to be exactly the same. My first task here is to place the letter J in the second position. So my first task is to place the letter J in the second position here. There's only one way I can do that. My second task is to choose another letter to go in the first position. There's 25 ways I can choose a letter to go in the first position. So notice, task 1 is to choose the letter J for the second position. Task 2 is to choose a different letter for the first position in here. Task 3 will be to choose a digit for the third position, 10 ways to do that. Task 4 will be to choose a different digit for the fourth position. So we get those things. Okay? So it's 1 by 25 by 10 by 9 plus 1 by 25 by 10 by 9. That's actually just 2 by 25 by 10 by 9. Which actually is pretty easy to do in your head. 2 25s, 50, 50 times 10, 500, 500 times 9, and 5 9s 45, so it's 4,500. There are 4,500, 4,500 ways I can form a code. How many ways? 45 4,100 ways or 4,500 ways I can form a code if I want my code to contain the letter J and to have no repeated digits. The key is to try to visualize exactly what's going to happen. I can put J in the first position, or I can put J in the second position. Break it down to a series of tasks. In the first approach, my first task is to place J in the first position. In the second approach, my first task is to place J in the second position. That's the only difference between them, really. Okay, but they look identical when written down. So that's the second fundamental principle of counting, section 5.1.3, or section 5.1 in your textbook. Practice, practice.